Hi everyone. Today we're going to look at exponential functions that have what is called base e. So this is called a natural base exponential function. So it has an equation that is f of x is equal to e to the x. So it's not really different than our exponential functions that we've been studying, but it has a base which is called e. Now, E is a number that we haven't talked about, like how can a letter be a number? But it's very similar to pi. It is a irrational, non-terminating, non-repeating number. So E is actually 2 point, I always forget, 2.71828 blah, 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 blah. Like pi, it's irrational, non-terminating, non-repeating decimal. And it's actually called the natural exponential because it's something that naturally occurs in math. And a lot of times it happens in your sciences. So if you think along the lines of like chemistry and decay and half-life and things along that lines, that's when you're going to see this a lot. All right. It was actually discovered by a mathematician named Euler. I believe he was Swiss, and he described the number and named it E. Now, he says, according to historical things, that it meant for exponential, not his name. That's still up for debate. So we're going to be working with E in the next couple, like today, and then the next couple of sections, because it is something that occurs naturally. It's something that you will be using in real life and application problems. So let's just get used to where it is on our calculator and how we're going to find some values of it. So you can find your graphing calculator if you have one. There are two places where you're going to find the letter E in your graphing calculator. It is above the division sign. So you can press second and then your division sign, and it's going to give you E. And you press enter and it'll give you 2.7182, blah, blah, blah. Or if you press second, and then you're going to see LN, which is to the left of the number 4. And that's going to give you E, and then it's going to give you like X or a little box and say input your exponent here. This is the one we're going to be using. It automatically already raises E to a power, and that's where you're going to put in your values like this one down here, 8, -3, 1/2. Now, if you don't have access to a graphing calculator, you can use the calculator that is on your iPad. So this is the calculator on the iPad. And if you notice over here on the left, there's an up arrow. And then above that is the LN button. And you see in the light gray E to the X. So if I press that up arrow, we get that second group, which has E to the X. And then up here, next to your pi button to the left, is the E button as well. And if you press E, it's going to give you that 2.71, da, 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 da. Okay? Now, if you're going to do E to the X, you have to put the number in first. So whatever power you want to take E to, that's the number you have to put in first. So let's say I want to do E to the 6th. I'm going to put 6 in, then I'm going to press E to the X. So it's a little different than our graphing calculators where you put that in and then put in the value. So here you're going to put the value in first and then press E to the X. Okay, so we'll do a couple using the calculator on the iPad, and then I'll use some of my graphing calculator here. All right, so here's some examples. I want to do E to the 3rd. So I'm going to pull up my calculator. I'm going to press 3EX, and I'm going to get 20.0. Let's make it 86. Okay. Okay. And again, I'm going to do E to the 8th. So I'm going to put in A, E to the X, 2,980. Let's make it 2,980.96. 2,980.96. 0.96. All right, so I'm going to just use my graphing calculator. So second e, -3. I'm going to get 0.0498, round to 4 decimal places. And then e to the 1/2. I'm going to get 1.64, make it 9. All right, so make sure that you can practice using your whatever calculator you have. And keep in mind, most calculators, and it doesn't have to be a graphing calculator, will have e to some power. All right, so let's graph him. So we've been graphing exponentials by using the x's as -1, 0, and 1. So let's do that. Now, e to the x, if you notice, e was 2.71. So this is an exponential growth problem. So he's growth, okay, because e is greater than 1. All right, so if we put this in, we're going to get 1 over that. So again, I'm just going to use my graphing calculator. 0.37. So 0 is going to be 1 because anything to the 0 power is 1. And this is going to be 2.712. All right, so let's graph that. It's not very nice numbers. All right, so let's just graph him, 0.37, 1 and 2.7, so somewhere up here. So he has a growth. So he has all the properties of growth, that our domain is greater, are all real numbers, that his answers are greater than or 0. So it's all those properties of growth problems. And again, you can transformation him, you can multiply and then pick it up and move it, and it's still going to have all of those properties. So the only thing is that our base is it's e, or 2.728, blah, 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 182, instead of like 5. Okay? All right, so why do we care? All right, why do I have to talk about this number e? Because e has a lot to do with money. All right, it is part of what is called compounding continuously formulas. Now, here's our compound interest formula. So if you're going to go to a bank and say, I want to invest money, what's your compounded rate? It could be compounded monthly, it could be compounded daily. So this particular formula is for compounding continuously. So if you want to think of continuously as the national debt, something that keeps going on every second, to keep going up and up and up and up. All right, that is compounding continuously. It's something that's constantly changing, whether it's increasing or decreasing. And this is a formula that we're going to use to represent that. So we have A of t, which stands for amount after time. So how much you have after a certain amount of time. You have P, which is your principal. It's how much money you invest, or your starting amount. How much money am I going to put in the bank? Okay, and then you have E. Okay, then you have R as your rate. We want to make sure that we write that as a decimal, 2 places to the left, people. And then you have T, which is your time, which is going to be in years. If it's not in years, then you have to make it in years. So if it says 6 months, we're going to write at 0.5. All right, so let's take a look at this. Suppose you won a contest at the start of 5th grade and deposited $3,000 in the account that pays 5% annual interest compounded continuously. How much would you have in the account when you enter high school 4 years later? All right, so we're going to use the amount after time formula. So PE to the RT, or sometimes you'll hear me call it PERT, and that's not the shampoo. So we started with $3,000. E 0.05 times 4. Okay, now keep in mind order of operations, guys. You have to do the e to the 0.05 times 4 first, then times that answer by 3,000. Okay, so I'm going to use my calculator here. Second ln or e, so 0.05 times 4, and then I'm going to take that answer and times it by 3,000. Okay, so I get $3,664.21, round to 2 decimal places because we are talking about money. That's how much you'll have when you enter high school. All right, so this is just a straight, here's how much money I have invest. My interest rate is 5.1% and my 3 years. So again, we're going to use our amount after time formula. So 2,000 E 0.051 times 3. Okay. And if you're going to use your graphing calculator, you can put a whole thing in all at once. I'm going to use my other calculator. Okay, so let's clear that out. Now I lost my track of what I was going to put in. 0.051 times e to the 0.051 times 3. Okay, so 0.051 times 3, I'm going to press equals, then I'm going to go e to the x, and times that by 3,000. All right, $3,495.97. Oh, it's 2,000. Let's try that again. All right, you know what? There we go. That's going to make it life easier. All right, so 0.051 times 3 equals okay, where'd my other thing go? Oops, sorry. I don't think that's right. There we are. Okay, let's try that again. All right, so 0.051 times 3. Okay, I'm going to do the, all right, times 2,000. There we go, 2,330. $0.65. Sorry about that. That's how much money we'll have left. Okay, let's try this last one. All right, so investing 2,000 in an account that pays 5 cents interest compounded continuously, and the same as investing $1,000 at 4% and $1,000 at 6%, each compounded continuously. All right, so are all 3 of those, when I add these 2 together, the same as the one at 5%? All right, so let's do 5% one. And we're going to say that this is 1 year. $2,102 and 54 cents. Okay, so let's do the 1,000. Okay, so 0.04 E times 1,000. 1,040.81 do the... Okay, 1,061. All right, so if I take these two and add them together, do I get the $2,102? Okay. And I get $2,102.65. And the answer would be almost the same. The two separate ones is 11 cents more. All right. Let me know if you have any questions, guys. Hope you have a great day. Remember, by staying in, we're going to keep each other safe. Talk to you soon.